Welcome to day 7 of our challenge. Today we'll focus on generating weighted population counts. Now the question obviously is, what are weighted counts? To answer this question, let's look at a surveillance report. Typically, you will find that in this report you might see statements like, in 2021, approximately 18.7%, which corresponds to 46 million of US adults currently used any tobacco products. Now, the question is, how do we come across this? How do we generate these numbers? There are two ways of generating these numbers, the wrong way and the right way. The wrong way will be to take this percentage and go to the US Census and take the number of adults from the census and multiply this percentage onto that number. That would be a wrong way of doing this because the sampling frame for this survey does not match perfectly to the total US adult population. Let's see that visually. Let's look at an analogy for that visually. This plot represents the total number of US adults in the population as captured from the census, and the cover of a plot in this analogy represents our sampling frame from which we are sampling for the NHIS. Now, if this sampling frame matched the adult population perfectly, this is what we would have on the left-hand side. But what we do have is the picture on the right, where you can see that the cover is much smaller than the pot. So it's not a perfect fit. Now, why is the cover much smaller than the pot? It's because there are several segments of a population that are excluded from the sampling frame. If you go back to the report and go to the method section, you will see that in NHIS, only individuals who are in households are surveyed, and only individuals who are described as part of a non-institutionalized US civilian population are surveyed. So this means that this survey excludes anybody who does not live in a household. For example, people who are homeless and live on the streets, people who live in military barracks, people who live in dormitories, people who live in other institutionalized settings like elderly care homes. All of those individuals are excluded from the NHIS. And of course, it also excludes those who are in the military. And that's why we have the scenario on the right-hand side where the cover does not match the pot perfectly. And this is why it would be incorrect for you to take a percentage that was calculated from the survey and apply it directly to the census to get those numbers. So no, we don't get these numbers by applying them to the census. So let's see how we calculate them, and we calculate them directly from the weight. Let's go to our tasks for today and see what we have been asked to do. For the first task, we have been asked to calculate the population counts for the number of US adults who reported current use of cigarettes, cigars, and these other tobacco products. And we've been asked to stratify by age and gender and to round the estimate to the nearest 10,000. So let's go to the chi-squares platform and let's do that accordingly. We'll go to estimate, we'll go to prevalence, and we'll select our outcome variables. These ones here. And our stratification variables are age and gender. Now here is the most important checkbox here as far as counts are concerned. Counts are calculated alongside prevalence estimates. So if you want to also get counts, you have to check this box here. So we're going to check this box and we will choose our desired rounding as 10,000. When you're calculating weighted counts, you don't want to be too precise. You don't want to say something like 1,234,567. That is way too precise. It almost gives the illusion that you were there counting the individuals one by one, which is obviously not the case. So we use 10,000 as a default for rounding when we calculate weighted count. So let's apply this and now let's estimate. Now, before you estimate, you should make sure that your data set is currently on weighted mode. As a matter of fact, you won't even see this checkbox if it's not on weighted mode. So now we can go ahead and estimate. So what the platform then does is it takes this outcomes you have provided and the stratification variables that have been supplied. It then estimates prevalence alongside with the weighted population counts, applying all the preferences that you selected in the rounding setup. In this case, we're applying the analysis to the entire data set among all adults. If we wanted a subset, we would have used this option here that says subset. For example, subset the analysis to American Indians, right? So now we have our results. Table 1 here is showing stratified prevalence estimates for the various outcomes, which are the different columns here. But what we're interested in now is the count. So let's scroll down to table 2, which shows the weighted population count. As you can see, this tells us that in that year, there were 25,190,000 individuals approximately who were current cigarette smokers. There were 17.79 million who reported current e-cigarettes in the overall population, and so on and so forth. Now, the next group shows the same numbers among the different subgroups that we have by age, by gender, and so on and so forth. So that's how you calculate weighted counts. This is how those numbers you read in federal surveillance reports are generated. Now let's go back to our task number 2. Task number 2 says we should create a new project and append 3 cycles of data, 2022, 2023, and 2024, so that now we want to calculate the same thing but among American Indians. Whenever we pull data sets together for estimation of prevalence, we need to pay special consideration to the weights. If we don't pay special consideration and recalibrate the weights, we're going to get 3 times the population size. So whenever you are trying to pull data sets together to increase sample size, like we have in this scenario, the first step you must do is to recalibrate the weight by dividing the weight variable by, in this case, 3. Why 3? Because we have 3 years we are putting together. So let's see how we do that. Let's go back to the Chi-Squares platform. This time we're going to create a new project so we don't mess up with the current project we have. Let's start new project and let's call this AIAN, American Indian or Alaska Native Prevalence, and counts, and let's proceed. We're going to upload our data sets. We'll start with the adults. When you are trying to append data sets, you have to start with 1, and then you can append the other ones onto that one. So we have loaded the 2022 data set. Now we are going to append the 2023 and 2024 onto this one. So we'll go to data processing, we'll come to combine data sets, and we'll come to append. And we can now upload the other 2 that we're interested in. Let's go to upload. My device, I'm going to select where the files are located. So 2023 and 2024, we will open those. We will upload them. Let's proceed. And so we have 2022, 2023, 2024. This is the current file that we read in first. Now we can append. Okay, append has been successfully done. Let's wait for the files to upload. So first things first, we are going to recalibrate our weight variable by taking the old weight variable and dividing it by 3. So let's go to data processing. We'll come to arithmetic transformations. We'll come to operations between a variable and a constant. The variable we want to transform is the old weight, WTFA. We select that and we enter the number 3 and we select divide. So take the original weight variable, divide it by 3 to give us a new weight variable, which we can call WTFA underscore A2 to tell us that this is the second weight, and let's transform this. So this is what we mean by recalibrating the weight. So now, whenever we're estimating prevalence with this combined data set, we will use this weight. So let's set the weight variable. We'll select the new one. Take note, this is the new one, number 2, not the old one. The PSU and the strata remain unchanged. So the stratum variable, that's pstrat, and we'll save. So now our analysis is in weighted mode. So if we were to estimate prevalence of cigarette smoking among American Indians, let's create a variable for smoking. SMK sig, this is the variable here. Let's quickly recode it. We're recoding such that 1 and 2 are together, then 3 and 4 are together, then 5 and 9 has to be set to missing. So we're going to mark them as missing, and we're going to edit this label and call that 1, and we'll edit this label and call that 0, and we're going to call this variable current cigarette. Okay, and that came from the codebook. The reason why I know those values is because I read the codebook. So you need to read the codebook. So now let's go and estimate now. So let's estimate the prevalence and the population counts for cigarette smoking. The stratification variables are gender, and let's select sex. In this case, I have not recorded those variables, but this is just a demonstration. But the exercise says you should record both sex or gender and age. And then in this case, we want to subset the analysis to individuals who are American Indians or Alaska Natives. From the manual, we are told, this is the designation here, this is a variable that indicates race or ethnicity, and American Indians or Alaska Natives are those with the value of 4. So we go back here and we want to subset this to the variable race, where the value is exactly equal to 4. We want to compute weighted count as well, and the desired rounding as usual is to the nearest 10,000. We're going to apply. And so the setup is prevalence of cigarette smoking, the stratification variables from the exercise, we're asked to stratify by age and gender. For the sake of this demo, I'm just choosing sex, but when you're doing yours, make sure you record the variables for gender and for age, so you have both variables here. I'm calculating weighted count as well, and this is supposed to be among the subgroup of individuals who identify as American Indians or Alaska Natives. So I'll estimate here. So this is going to take the exact same thing and calculate it, but this time among the subset. One thing we must point out is that the recalibration we have done affects only the weighted count. The recalibration has no impact on prevalence itself. So whether we use the old weight variable or the new one, your prevalence estimates are going to be exactly the same. And that's an exercise I will encourage you to practice, to see it for yourself, that recalibration of weights has no impact on the prevalence estimates themselves. The only thing that it affects are the weighted counts. So in this case, we've combined data from 3 cycles, and so recalibrating it makes sure that our generated numbers for the count will still sum up to the US total population and not give us 3 times the size of the US population. So those are some of the things you want to watch out for when you're doing the practice exercise. So let's give it a few seconds for it to calculate, and then we can close this task. All right, so here we have the prevalence calculated for overall and by gender. We should have done a good job of recoding, but we didn't do that. But when you're doing your own analysis, make sure you recode these categories accordingly. And so here you have the weighted counts for overall and for the different categories of gender accordingly. Like I said earlier, try to practice with using the old weights and the new weights. You will find that regardless of the weight you use, this prevalence estimates will remain exactly the same, but what changes will be the counts. So we recalibrate to preserve the validity of the counts, but recalibration has no impact whatsoever on the prevalence estimates themselves. Thank you very much.